And most of the remons or the sum problems are connected to, is this an over or an underestimate of the actual value? Okay, so what we need to do, just want to show you how that works, but I'm going to have you guys do a lot of the thinking by comparing and contrasting different types of functions to see if we can figure it out. Okay. So I'm going to draw 4 left Riemann sums on the board. And we're going to see if you can identify how to tell if these are over or underestimates. Okay. There's 2. Why am I drawing a blank? No.
I think he does a bad thing, so I don't want to do it.
Okay. Those are the 4 left Riemann sums you need to see to be able to figure out over and underestimates. So go ahead and write them down. Okay, label if each of those, if you think, which ones you think are over and underestimates.
Is there a relationship with the
Not the two of them. It's terrible.
Why is it varied by region?
Not here.
This is all region.
But we rested our tires. Okay, all right, what can you tell me about this graph? Okay, so we're an underestimate. David, what'd you say? Concave up? What else? Increasing. Okay. Same thing here. Underestimate. Right? Concavity. And increasing or decreasing? Increasing, because you're going up to the right still. Okay. Same thing here. Overestimate. Concave up and decreasing. Okay? And overestimate. Concave down and okay. Can you figure out when to know the left Riemann sum is an underestimate and when it is an overestimate based on the information up there? No, I said, can you figure it out? You give me a summary. If the function is decreasing, then
it'll be an overestimate of the area of the curve.
Then the left Riemann sum.
Okay. Does anybody disagree?
Nope.
All right, what about underestimates?
If the function is increasing.
The function is increasing, the left Riemann sum is an
Underestimate.
underestimate. Congratulations. You just won a point on the AP exam. That exact statement is what you need to write. So, here you go. Increasing, underestimates, right? Concave up, concave down. Those do not match. Okay? Riemann sums are solely based on increasing and decreasing functions. Okay? They'll have over and underestimate. So, the left Riemann sum is an underestimate if the function is increasing. Okay? Conversely, a left Riemann sum is an overestimate if the function is decreasing. Okay? Again, concavity does not match here, right? You want me to write those statements down? Yes or no? You did. Okay, well, you figured it out, so. Okay, do you want me to do the same thing with right Riemann sum?
Sure.
I'm guessing it's opposite. It's going to be opposite.
You're guessing? There's two. Not my best piece of work. But it doesn't fall out.
Hey, Google. Yeah, so it's the exact opposite of the left Riemann sum.
That it is. So, overestimate, right? Increasing, concave up, increasing, concave down. Notice concavity does not match, but increasing and over does, right? So, that's your info there. And then the same thing here.
Those are right remote zones?
Yeah. So, under. With decreasing. Again, concavity does not have a bearing on that information. You would say the left Riemann sum is an overestimate because the function is decreasing. The right Riemann sum is an overestimate because the function is increasing. Okay?
Yep.
There you go.
This isn't that bad. Is this all it is?
Well, you have to, so how do we calculate increasing, decreasing? Algebraically.
Okay. So would you have to back split this
You
up?
might have to. Do what?
Justify.
Okay, so you justify your answer. How would I justify that that function is increasing algebraically?
Your slope.
So let's say I give you this. Okay, how do I know that function is increasing? Where is it increasing? This is a big part of first semester. The derivative is positive. And so y prime is 2x. What do we do with the derivative? Set it equal to 0. And solve, right?
Yep.
Okay. Now what do we do to figure out increasing, decreasing, or min-max? We do a sign analysis. So the derivative at -1 and the derivative at 1.
Oh,
If the function is decreasing, the function is, okay. So a right Riemann sum would be a underestimate here. And the left Riemann sum would be an overestimate.
If it's decreasing.
yes.
Okay. Here, a right Riemann sum would be
Oh,
an overestimate. And the left Riemann sum would be an underestimate. Okay? So you might have to justify your answer there.
okay.
Right? Questions? Here's one more. Trapezoidal. We don't worry about midpoint because it's kind of impossible for us to tell. Okay, trapezoidal.
Welcome.
Okay, there's the four situations for trapezoidal sum. You make that connection.
So it has to do with the concept.
So this is an overestimate, right?
Yeah.
We are concave up
Yeah.
and
Increasing. That's an under.
under, concave
Down.
down,
In.
increasing. So do the increasings match with over and under?
No.
Okay, so we know that increasing does not have a bearing for trapezoidal sums on this. Okay. So obviously concavity, right?
Yep.
Let's look at another concave up. Is that an overestimate?
Yes.
Yeah, it is. Okay, so with trapezoidal sums, overestimates are because of concavity. So we have concave up. Underestimates, concave down, right?
Yep.
So Riemann sums depend on increasing and decreasing. Trapezoidal sums depend on concavity. Okay?
And this one we would just prove with the second derivative.
Yes, you might have to use the second derivative to justify your answer. So we just use the same function we did last time. Okay. Second derivative is 2. Do I even need to do a sign analysis? Why not?
Analyze.
Always positive, right? Because 2 is positive, right? So second derivative is always positive. So a trapezoidal sum with that function would be an, we have a concave up, so trapezoidal sum would be a
Overestimate.
overestimate. Trapezoidal sum. Overestimate. Okay?
Okay.
Any questions? Again, some of your comments on that survey I sent out were that what we do in class seems easy, and then I give you the work and it's harder, right? Okay, the work for the weekend is 2 AP problems, I think, maybe 3. It's problems from the AP exam.
Okay.
So you're going to be calculating left, right, trapezoidal, and midpoint sums still. And then you're probably going to have to use these techniques to show increasing, decreasing, concave up, concave down, and under and over estimates. Okay? So, put your thinking caps on. You might have to sit there.
Okay, you just wait for the snow clouds.
Again, feedback was you need free response work, so got it. You're probably going to have some derivatives on there, right? It should be posted, yeah.
It is.
So you're going to be working with all our work from semester 1 and some of this new stuff today.
Okay.
And keep in mind, you have 15 minutes per problem on the AP exam phase. So this is not something you just sit down and do in 5 minutes. Okay? One of these might take you at this point 20, 30 minutes. If you sit down and you try, it might take you longer than 15 minutes right now. Okay, so think it through. Don't just look at it and say, I don't know. I told you in college I had problems where I sat there and I looked at it for 3 hours until I figured it out. Okay? So think it through.
What? No, it's not my dream. I did them.
I feel like they're all what he talked about yesterday.
Yeah. That's it.